Across the ocean floor, a vast network of linear structures stretches through the Atlantic, Indian, Pacific, and Southern Oceans. When viewed on a global seafloor map, these structures form a continuous framework that circles the planet. This immense system is known as the Mid-Ocean Ridge Network, one of the longest connected geological structures on Earth. In this video, we will look at how mid-ocean ridge systems are arranged across the world ocean. The ridge network appears as long corridors that cross entire ocean basins, linking distant regions of the seafloor. Along these corridors, ridge axes are divided into segments, organized into basin-scale sectors, and connected through junction regions where multiple ridge systems meet. We will also look at the structural frameworks used in seafloor mapping. These include segmentation systems that divide ridge axes into structural sections, reference grids that record ridge locations using global coordinates, and indexing structures that catalog ridge corridors across different ocean basins. Together, these mapping systems reveal the large-scale organization of the global ridge network. Before the video continues, take a moment to settle in. If you're watching in the evening, try lowering the lights in the room or dimming your screen. Let your shoulders relax, loosen your body, and take a slow, calm breath. There's no need to focus on every detail. Many people enjoy listening to gentle science like this while resting or slowly drifting into sleep. If you enjoy slow, relaxing science like this, consider subscribing to the channel. You can also leave a like and share your thoughts in the comments below about topics you would like to hear in future videos. Mid-ocean ridge systems form a continuous structural network across the global ocean floor. The distribution map, commonly used in geophysical reference materials, presents this network as a connected set of linear features extending through multiple ocean basins. These ridge alignments outline one of the largest continuous physical structures on Earth. A prominent ridge corridor extends through the center of the Atlantic Ocean. This corridor follows a north-south alignment that spans from the Arctic Ocean region to high southern latitudes. The ridgeline remains visible across most basin-scale maps as a central dividing structure within the Atlantic Basin. Additional ridge corridors appear across the Indian Ocean basin. Several major segments extend between Africa, Antarctica, and Australia. These segments form a connected network that links to adjacent ridge systems at several junction regions. Large ridge corridors also occupy the Eastern Pacific Basin. These corridors form extended linear structures across the ocean floor, positioned between continental margins and open basin regions. Mapping references commonly depict these segments as part of a larger interconnected ridge framework. The global ridge network continues into the Southern Ocean, where multiple ridge corridors connect Atlantic, Indian, and Pacific ridge systems. These 7 segments appear as linking structures that maintain continuity between basin-scale ridge networks. Global ridge distribution maps typically display these corridors as long, segmented lines, forming a planetary scale system. Individual ridge sections appear connected across ocean basins through a network of junction regions and extended ridge alignments. This mapped structure presents mid-ocean ridges as a continuous geophysical framework spanning the majority of the ocean floor. The distribution pattern remains consistent across modern global seafloor mapping references and geophysical survey compilations. The Atlantic Ridge System corridor occupies a central position within the Atlantic Ocean basin. On global seafloor distribution maps, this corridor appears as a continuous north-south ridge alignment extending through the length of the basin. The ridge corridor separates the Atlantic Basin into 2 broad regions positioned on either side of the central ridge structure. In northern sections of the basin, the ridge alignment extends from the Arctic Ocean region into the North Atlantic Basin. The ridgeline continues southward through the central Atlantic area with only minor lateral deviations in its mapped path. Basin scale maps consistently represent this corridor as a dominant linear feature across the seafloor. The corridor passes through several broad Atlantic regions, including the North Atlantic, Equatorial Atlantic, and South Atlantic sectors. Across these sectors, the ridge alignment maintains a generally continuous orientation that remains visible across most global ridge distribution datasets. Multiple ridge segments appear along the corridor. These segments form a connected sequence that preserves the overall north-south corridor alignment across the basin. Mapping references typically depict these segments as parts of a larger ridge corridor extending across the Atlantic. In the southern portion of the basin, the ridge corridor continues toward high southern latitudes, where it connects with additional ridge structures in the Southern Ocean region. These connections form junction regions, linking the Atlantic Ridge Corridor to other basin-scale ridge systems. Global ridge distribution maps consistently portray the Atlantic Corridor as one of the longest continuous ridge alignments in the world ocean. Its position along the central axis of the Atlantic Basin provides a clear spatial reference for the arrangement of ridge systems across this ocean region. Several mid-ocean ridge corridors extend across the Indian Ocean basin. On global ridge distribution maps, these corridors appear as interconnected ridge alignments positioned between the continental margins of Africa, Antarctica, Australia, and Southern Asia. The arrangement forms a branching network across the central and southern parts of the basin. One major corridor extends from the southern Atlantic Indian connection region toward the central Indian Ocean. This ridge alignment continues eastward across the basin as a long linear structure that maintains a clear position in global ridge mapping references. The corridor links to additional ridge structures located farther east in the ocean basin. Another ridge corridor appears between Africa and Antarctica in the southwestern Indian Ocean region. This alignment forms a continuous ridge path that curves across the basin while maintaining connection with neighboring ridge systems. Basin-scale maps consistently depict this corridor as a major structural component of the Indian Ocean ridge network. An additional corridor extends between Antarctica and Australia across the southeastern Indian Ocean. This ridge alignment continues for long distances across the basin and remains visible in global seafloor mapping datasets as a connected sequence of ridge segments. The Indian Ocean ridge corridors converge near several junction regions where multiple ridge alignments meet. These junction areas form connection points linking the Indian Ocean ridge network to ridge systems in adjacent ocean basins. Across the basin, ridge corridors appear as segmented but continuous linear structures, forming an interconnected framework on the ocean floor. Global ridge distribution maps consistently present these corridors as integral components of the wider mid-ocean ridge network, spanning multiple ocean basins. Several mid-ocean ridge corridors extend across the Pacific Ocean basin. On global ridge distribution maps, these corridors appear as long linear ridge alignments, positioned across the eastern and southeastern sectors of the basin. The mapped corridors form part of the broader global ridge network that connects ridge systems across multiple ocean regions. One major corridor extends through the eastern Pacific region. This ridge alignment runs roughly north-south across large portions of the basin and remains visible across most global seafloor mapping references. The corridor occupies a position between the continental margins of the Americas and the Central Pacific Basin. The ridge corridor continues across a sequence of ridge segments that form a continuous alignment through the Eastern Pacific seafloor. These segments appear as linked structural units that maintain the general orientation of the ridge corridor across the basin. Additional ridge alignments extend across the southeastern Pacific region toward high southern latitudes. These corridors connect the eastern Pacific ridge structures with ridge systems located in the Southern Ocean. Global ridge distribution maps commonly represent these alignments as extensions of the Pacific Ridge framework. The Pacific Ridge corridors form junction regions where ridge alignments meet other basin-scale ridge systems. These junction areas appear in mapping references as connection points linking the Pacific Ridge corridors to adjacent ridge networks. Across the Pacific Basin, ridge corridors appear as elongated segmented structures, forming part of a continuous global ridge system. Seafloor mapping datasets consistently depict these corridors as major components of the planetary-scale mid-ocean ridge network. The Southern Ocean contains several ridge sectors that form connecting segments between major mid-ocean ridge systems. On global seafloor distribution maps, these sectors appear as extended ridge alignments surrounding the Antarctic region. The mapped network links ridge systems from the Atlantic, Indian, and Pacific Ocean basins. One ridge sector extends southward from the Atlantic basin toward the waters surrounding Antarctica. This ridge alignment continues from the southern portion of the Atlantic Ridge Corridor and maintains a connected path across the seafloor. Global ridge maps consistently display this structure as part of the broader ridge framework surrounding the Antarctic region. Another ridge sector appears between the southern Indian Ocean and the Antarctic margin. This ridge alignment forms a continuous connection between Indian Ocean ridge corridors and adjacent ridge structures located farther east. Basin-scale mapping references depict this sector as a linking element between ridge systems of the southern hemisphere. Additional ridge segments extend across the southeastern waters surrounding Antarctica. These alignments connect ridge corridors of the Pacific Basin with ridge structures that encircle the Antarctic region. The napped structures form a sequence of linked ridge segments extending across large areas of the Southern Ocean. Across the Antarctic perimeter, ridge sectors appear as interconnected structural corridors positioned along the ocean floor surrounding the continent. These corridors form part of the continuous global ridge network that spans multiple ocean basins. Global ridge distribution maps consistently represent the Southern Ocean ridge sectors as linking structures between major ridge systems. The network surrounding Antarctica maintains spatial continuity between Atlantic, Indian, and Pacific ridge corridors within the global mid-ocean ridge framework. Interbasin ridge junction regions appear at locations where major mid-ocean ridge corridors from different ocean basins converge. On global seafloor distribution maps, these regions form structural connection points, linking ridge systems that extend across separate oceanic basins. The junction areas represent intersections within the broader planetary ridge network. One prominent junction region appears between the Atlantic and Indian Ocean ridge corridors. In global ridge mapping references, this region forms a meeting point between ridge alignments extending from the southern Atlantic basin and ridge corridors positioned across the southwestern Indian Ocean. The junction connects these basin-scale ridge systems through a shared structural intersection. Another junction region occurs where Indian Ocean ridge corridors approach ridge systems of the Southern Ocean. In this region, multiple ridge alignments converge across seafloor sectors surrounding the Antarctic region. Mapping datasets consistently depict these connections as intersections linking ridge structures across basin boundaries. A further junction region appears between ridge corridors extending from the Pacific Basin and ridge systems located in the Southern Ocean. This junction forms a structural link between the Eastern Pacific Ridge Framework and ridge alignments positioned around the Antarctic perimeter. Interbasin junction regions often contain several connected ridge segments arranged around a central intersection area. These segments extend outward into different ocean basins, forming branching connections between ridge corridors. Global ridge distribution maps consistently portray these junction regions as nodes in the larger ridge network. The intersections connect ridge corridors from multiple ocean basins and maintain spatial continuity across the worldwide mid-ocean ridge system. Mid-ocean ridge axes are commonly represented as segmented linear structures across global seafloor maps. The segmentation framework divides the ridge axis into a series of connected structural units positioned along the length of the ridge system. Each unit forms a defined section of the ridge axis within the overall ridge corridor. Global mapping references often display ridge axis as sequences of adjacent segments rather than as uninterrupted lines. These segments appear separated by structural offsets or discontinuities that partition the ridge axis into multiple sections. The segmentation pattern remains visible across ridge systems in different ocean basins. Segment boundaries appear at intervals along the ridge axis, where the linear alignment changes direction or becomes offset relative to neighboring sections. These boundaries form reference points that separate one ridge segment from the next. Seafloor mapping datasets frequently represent these boundaries as small lateral displacements or breaks along the ridge trace. Within the segmentation framework, individual ridge segments appear as elongated structural units, extending between adjacent boundaries. Each segment maintains a consistent ridge alignment along its length before reaching the next segmentation boundary. Global ridge datasets commonly catalog these segments as part of larger ridge system inventories. The segmentation framework provides a structural method for organizing ridge axes across long ridge corridors. Mapping systems often index ridge segments according to their position along the ridge axis and their relationship to neighboring segments. Across global ridge networks, segmentation patterns appear repeatedly along ridge corridors in the Atlantic, Indian, Pacific, and Southern Ocean regions. The framework organizes ridge axes into structured sequences of connected segments distributed across the ocean floor. Major ridge segment divisions appear as large structural partitions along the axes of mid-ocean ridge systems. Global seafloor mapping datasets often represent ridge corridors as series of extended segments separated by major discontinuities. These divisions organize ridge axes into broad structural sections distributed across the ocean floor. Each major division occupies a substantial portion of a ridge corridor. The divisions extend between prominent segmentation boundaries that separate one large ridge section from another. Mapping references frequently display these boundaries as lateral offsets or shifts along the ridge trace. Across basin-scale ridge corridors, major segment divisions maintain relatively consistent ridge alignment over long distances. These sections appear as elongated linear structures positioned between major segmentation breaks. The boundaries between divisions form clear partition points in many global ridge mapping compilations. In the Atlantic Ridge Corridor, several large divisions appear along the length of the ridge axis. Comparable structural divisions appear across ridge systems in the Indian Ocean and Pacific Ocean basins. Global ridge maps commonly depict these divisions as large-scale partitions along the ridge network. Major segment divisions often contain multiple smaller ridge segments positioned along the same ridge axis alignment. These internal segments form secondary partitions inside the larger structural division. Mapping systems frequently catalog these hierarchical relationships between major divisions and smaller segments. Across the worldwide ridge network, the pattern of major segment divisions appears repeatedly along ridge corridors in multiple ocean basins. The divisions organize ridge axes into extended structural sections that remain identifiable across many global seafloor mapping datasets. Intermediate segment groupings appear as structural units positioned between large ridge divisions and smaller ridge partitions along mid-ocean ridge axes. Global seafloor mapping references commonly display these groupings as clusters of adjacent ridge segments arranged along the ridge corridor. Each grouping forms a recognizable section of the ridge axis, located between larger structural breaks. These groupings typically contain several ridge segments that share a similar alignment along the ridge axis. The segments appear connected in sequence and remain positioned between neighboring segmentation boundaries. Mapping datasets often present these groupings as coherent structural intervals along the ridge corridor. Intermediate groupings occur across ridge systems in multiple ocean basins. The Atlantic Ridge Corridor contains numerous groupings arranged along its central axis. Comparable structural clusters appear along ridge systems in the Indian Ocean and Pacific Ocean basins. The boundaries between groupings correspond to distinct segmentation breaks that partition one cluster of ridge segments from the next. These partition points create a repeating pattern of grouped ridge segments along the length of the ridge axis. Global ridge mapping compilations frequently catalog these boundaries as intermediate segmentation markers. Within each grouping, ridge segments remain aligned along a common axis orientation across the seafloor. The grouped segments extend across moderate distances before reaching the next segmentation boundary. Mapping references commonly display these clusters as intermediate structural sections along the ridge network. Across global ridge systems, intermediate segment groupings appear repeatedly between major ridge divisions and smaller structural partitions. The grouping framework provides an additional structural level for organizing ridge segments along long ridge corridors in the world ocean. Minor segment partitions appear as small-scale structural divisions along mid-ocean ridge axes. Global seafloor mapping references often represent ridge corridors as sequences of closely spaced segments separated by minor discontinuities. These partitions divide larger ridge sections into shorter structural sections along the ridge axis. Minor partitions occur at short intervals along many ridge corridors. The boundaries between partitions appear as slight offsets or changes in ridge alignment across the mapped ridge trace. Seafloor mapping datasets frequently display these divisions as small breaks along otherwise continuous ridge segments. Each partition defines a limited section of the ridge axis positioned between two adjacent minor boundaries. These sections maintain a consistent ridge alignment across their length before reaching the next partition point. Mapping references often catalog these units as the smallest structural divisions within ridge segmentation systems. Minor segment partitions appear repeatedly along ridge systems in several ocean basins. The Atlantic Ridge Corridor contains numerous small structural sections separated by closely spaced boundaries. Comparable partition patterns occur along ridge axes in the Indian Ocean and Pacific Ocean regions. A partition pattern forms a repeating sequence of short ridge sections arranged along the ridge corridor. Each section occupies a defined position relative to neighboring partitions along the ridge axis. Global ridge mapping compilations commonly represent these units as the finest level of structural segmentation along ridge corridors. Across the worldwide ridge network, minor segment partitions appear in large numbers along extended ridge alignments. These small structural divisions provide detailed partition references along the axes of mid-ocean ridge systems mapped across the ocean floor. Transform offset segment boundaries appear as lateral displacements along mid-ocean ridge axis, where adjacent ridge segments shift relative to each other. Global seafloor mapping references commonly depict these boundaries as locations where the ridge axis is interrupted and laterally repositioned before continuing along a new alignment. The offset configuration creates a stepped pattern along the ridge corridor. Each transform offset boundary separates two ridge segments positioned on parallel or slightly angled alignments. The ridge trace on one side of the boundary appears displaced relative to the segment on the opposite side. Global ridge distribution maps frequently represent these boundaries as sharp lateral offsets connecting adjacent ridge sections. The boundaries form recognizable structural markers along many ridge systems. In mapping datasets, Transform offset locations appear repeatedly along ridge corridors across multiple ocean basins. The Atlantic Ridge Corridor contains numerous offset boundaries positioned along its central ridge axis. Comparable patterns occur along ridge corridors in the Indian Ocean and Pacific Ocean regions. Transform offset boundaries organize ridge segmentation by separating adjacent ridge segments into distinct structural units. Each ridge segment terminates at one boundary and resumes beyond the offset location as a continuation of the ridge axis. Mapping references commonly depict these configurations as alternating ridge segments and offset connectors. Across global ridge networks, transform offset boundaries occur at varying intervals along ridge corridors. Some ridge segments extend across considerable distances before reaching an offset boundary, while other segments appear separated by more closely spaced offsets. Global seafloor mapping compilations consistently display these offset boundaries as a common structural feature along ridge axes. The pattern of lateral displacements contributes to the segmented arrangement of mid-ocean ridge systems mapped across the ocean floor. Non-transform discontinuity sectors appear as interruptions along mid-ocean ridge axes, where adjacent ridge sectors do not align directly across a lateral offset structure. Global seafloor mapping references commonly depict these sectors as locations where the ridge axis changes position or orientation without a clear transform offset connector. The discontinuity results in a gap or step between neighboring ridge segments. These sectors separate ridge segments that terminate near each other but do not connect through a continuous linear boundary. On seafloor distribution maps, the ridge trace may appear shifted, curved, or repositioned across the discontinuity sector. The adjacent ridge segments continue along new alignments beyond the boundary. Non-transform discontinuity sectors occur along ridge corridors in multiple ocean basins. Several examples appear along the Atlantic Ridge Corridor, where neighboring ridge segments meet across short spatial gaps. Comparable sectors occur along ridge systems mapped in the Indian Ocean and Pacific Ocean basins. Mapping datasets frequently represent these discontinuities as small breaks between ridge segments, where no clear lateral connector is present. The ridge axis resumes on the opposite side of the sector with a slightly modified alignment relative to the preceding segment. These sectors function as segmentation boundaries within ridge axis partition systems. Each discontinuity sector separates adjacent ridge segments and marks a structural transition along the ridge corridor. Across global ridge networks, non-transform discontinuity sectors appear repeatedly between ridge segments distributed along long ridge corridors. Seafloor mapping compilations consistently catalog these sectors as a common type of segmentation boundary along mid-ocean ridge axes. Triple junction locations appear at points where three mid-ocean ridge segments converge on the ocean floor. Global seafloor mapping references commonly catalog these locations as structural nodes within the worldwide ridge network. Each junction marks the intersection of three ridge alignments, arranged around a central meeting point. Global ridge catalogs typically identify several triple junction regions distributed across different ocean basins. These locations appear in mapping datasets as geometric intersections between ridge corridors extending in separate directions. The ridge segments meet at defined angles that form a three-armed junction pattern on seafloor distribution maps. One widely mapped example occurs in the southern Atlantic, Indian Ocean sector, where three ridge alignments meet near the southern oceanic boundary between those basins. Another example appears in the central Indian Ocean region, where multiple ridge corridors intersect across a defined junction area. Mapping compilations consistently record these locations as triple ridge intersections. Additional triple junction regions appear in the Pacific and Southern Ocean sectors. These junctions connect ridge segments extending across large ocean basins and appear in global ridge inventories as key intersection nodes along the ridge network. Global ridge catalogs usually record each triple junction using geographic coordinates and associated ridge segment identifiers. The catalog entries organize junction regions according to their ocean basin location and their relationship to neighboring ridge corridors. Across worldwide seafloor mapping datasets, triple junction regions form a distributed set of structural nodes linking multiple ridge systems. These catalog locations represent points where three ridge alignments meet within the broader mid-ocean ridge network mapped across the global ocean floor. Atlantic-Indian ridge junction sectors appear in regions where ridge corridors from the Atlantic basin connect with ridge alignments extending across the Indian Ocean basin. Global Seafloor mapping references display these sectors as structural intersection zones, linking ridge systems across the boundary between the two ocean basins. The sectors form transition regions where ridge corridors converge. One major junction sector occurs in the southern oceanic region between the southeastern Atlantic basin and the southwestern Indian Ocean. In global ridge distribution maps, this area contains several ridge segments that intersect across a defined junction zone. The connected segments extend outward toward both the Atlantic Ridge Corridor and the ridge corridors of the Indian Ocean. The junction sector includes multiple ridge alignments arranged around the intersection area. These alignments extend into separate basin-scale ridge systems while maintaining structural connection across the junction region. Seafloor mapping datasets frequently represent these sectors as meeting zones between ridge corridors of neighboring ocean basins. Additional Atlantic-Indian junction sectors appear in nearby southern oceanic regions where ridge corridors approach one another across basin boundaries. These sectors contain ridge segments positioned at different orientations relative to the surrounding ridge systems. Mapping compilations commonly represent the sectors as nodes where ridge corridors from two ocean basins intersect through shared structural regions. The intersecting ridge alignments form a network of connected segments across the junction zone. Across global ridge network maps, Atlantic-Indian ridge junction sectors appear as structural links between two major ocean basin ridge systems. These sectors mark locations where ridge corridors converge across the boundary separating the Atlantic and Indian Ocean ridge networks. Pacific, Antarctic ridge junction sectors appear in regions where ridge corridors from the Pacific Ocean basin connect with ridge alignments that extend across the Southern Ocean surrounding Antarctica. Global seafloor mapping references display these sectors as intersection zones where ridge segments from different basin-scale systems meet across shared structural regions. The sectors form connection areas linking the Pacific Ridge framework with ridge networks encircling Antarctica. One major junction sector occurs in the southeastern Pacific region, where ridge corridors approach the Antarctic Ridge network. In global ridge distribution maps, this area contains several ridge segments that intersect across a defined junction zone. The connected segments extend outward toward the Pacific Ridge corridor and toward ridge alignments positioned around the Antarctic margin. Within the junction sector, multiple ridge segments appear arranged around the intersection region. Each segment extends toward a separate ridge corridor, belonging to either the Pacific Basin or the Southern Ocean Ridge network. Mapping datasets frequently represent these arrangements as branching ridge alignments converging at the junction sector. Additional Pacific, Antarctic junction sectors appear along the southern boundary of the Pacific Basin, where ridge corridors reach the Antarctic Ridge system at several points. These sectors contain ridge segments oriented along different directional alignments relative to surrounding ridge corridors. Global seafloor mapping compilations commonly portray these junction sectors as nodes linking ridge corridors from the Pacific Basin with ridge networks surrounding Antarctica. The intersection zones contain several ridge segments arranged around a central meeting area. Across global ridge network maps, Pacific, Antarctic ridge junction sectors function as structural connection regions between major ridge systems of the Pacific Ocean and the Southern Ocean Ridge Framework. Indian Ocean triple junction regions appear at locations where three ridge corridors intersect across the Indian Ocean basin. Global seafloor mapping references commonly represent these regions as geometric intersection points connecting three ridge alignments. Each region forms a structural node within the broader network of mid-ocean ridge systems. One widely mapped triple junction region occurs in the central Indian Ocean, where ridge corridors extending toward Africa, Antarctica, and Australia converge. On global ridge distribution maps, the three ridge alignments meet at a defined intersection area, where each corridor extends outward in a separate direction. The arrangement forms a characteristic three-armed junction pattern on the seafloor. Additional triple junction regions appear in the southwestern and southeastern sectors of the Indian Ocean basin. These regions occur where ridge corridors linking the Atlantic-Indian Connection Zone, the Antarctic Ridge Network, and Indian Ocean ridge alignments converge. Seafloor mapping datasets consistently depict these areas as intersection modes among ridge corridors. Within each triple junction region, three ridge segments approach a shared intersection zone from different directions. The ridge corridors extend outward from the junction and continue across separate portions of the ocean basin. Global ridge inventories frequently catalog these locations using geographic coordinate references and associated ridge segment identifiers. Mapping compilations often represent Indian Ocean triple junction regions as part of the global catalog of ridge and section nodes. Each entry records the location where three ridge corridors meet across the seafloor network. Across worldwide ridge mapping datasets, the Indian Ocean basin contains several catalogued triple junction regions. These regions connect multiple ridge corridors and form structural intersection points within the global mid-ocean ridge framework. Southern Ocean Ridge intersection regions appear at locations where ridge corridors from different ocean basins meet across the seafloor surrounding Antarctica. Global seafloor mapping references depict these regions as intersection zones linking ridge systems from the Atlantic, Indian, and Pacific Oceans. The regions form structural connection areas within the ridge network encircling the Antarctic continent. Several intersection regions occur where ridge corridors from neighboring ocean basins approach the Antarctic ridge framework. In global ridge distribution maps, these areas contain ridge segments that meet or cross across defined seafloor sectors. The intersecting alignments extend outward into separate ridge corridors that continue across adjacent ocean basins. One group of intersection regions appears where ridge corridors from the southern Atlantic basin connect with ridge segments of the Antarctic ridge network. Another group occurs where ridge alignments from the Indian Ocean approach ridge corridors that extend along the Antarctic perimeter. Additional intersection regions appear along the southern boundary of the Pacific Basin, where Pacific ridge corridors connect with Antarctic ridge structures. Within each intersection region, multiple ridge segments approach a shared structural area from different directional alignments. The ridge segments extend away from the intersection towards separate ridge corridors across surrounding ocean basins. Global mapping datasets frequently depict these arrangements as clusters of ridge alignments converging across defined seafloor sectors. Seafloor mapping compilations commonly catalog Southern Ocean Ridge intersection regions using geographic coordinate references and associated ridge segment identifiers. Each catalog entry records the intersection between ridge corridors belonging to different ocean basin systems. Across global ridge network maps, these southern ocean regions appear as structural intersections connecting ridge systems from multiple ocean basins around Antarctica. Multi-ridge connection nodes appear at locations where several ridge corridors intersect or converge across the global ocean floor. Global seafloor mapping references commonly represent these nodes as structural junction areas, linking multiple ridge segments belonging to different ridge systems. The nodes form intersection points within the broader network of mid-ocean ridges. At each connection node, several ridge segments approach a shared structural area from different directional alignments. The ridge segments extend outward from the node towards separate ridge corridors distributed across surrounding ocean basins. Seafloor mapping datasets frequently depict these nodes as central points where multiple ridge traces converge. Multi-ridge connection nodes occur across several oceanic regions. Some nodes appear in the Southern Ocean, where ridge corridors from the Atlantic, Indian, and Pacific systems approach one another near the Antarctic perimeter. Additional nodes appear within the Indian Ocean basin, where several ridge corridors intersect across defined seafloor sectors. In global ridge distribution maps, these nodes appear as meeting points that connect ridge segments arranged in multiple orientations. The ridge corridors extending from each node continue across different portions of the ocean floor, linking separate sections of the global ridge network. Mapping compilations commonly catalog these nodes using geographic coordinate references and associated ridge segment identifiers. Each catalog entry records the structural location where multiple ridge alignments intersect across the seafloor. Across worldwide seafloor mapping datasets, multi-ridge connection nodes appear as distributed junction points linking ridge corridors across the global mid-ocean ridge system. The nodes contribute to the interconnected structure of ridge networks spanning multiple ocean basins. Global ridge system length references appear in seafloor mapping compilations that record the total linear extent of mid-ocean ridge networks across the world ocean. These references organize ridge corridors into measurable structural lines that extend across multiple ocean basins. The length references provide a standardized way to catalog the scale of ridge systems within global geophysical datasets. In many mapping inventories, the worldwide ridge network is represented as a continuous set of connected ridge corridors extending across the Atlantic, Indian, Pacific, and Southern Oceans. The full network length is typically recorded as a cumulative measurement of all ridge segments included within the mapped ridge system. This measurement represents the combined linear extent of the global ridge framework. Individual ocean basins also contain length references for their primary ridge corridors. The Atlantic Basin contains a long ridge corridor extending across the central region of the basin from northern to southern latitudes. The Indian Ocean Basin contains several ridge corridors that contribute additional linear distance to the global ridge system. The Pacific Basin also contains extended ridge corridors that add to the total mapped ridge length. Mapping references frequently calculate these measurements by summing the lengths of individual ridge segments along the ridge axis. Each segment contributes a defined linear distance to the overall ridge corridor measurement. Segment length values appear in ridge catalogs and seafloor mapping databases. Global ridge system length references therefore appear in datasets as cumulative measurements derived from many connected ridge segments distributed across the ocean floor. These measurements provide a spatial index describing the overall linear extent of the mid-ocean ridge network mapped throughout the world ocean. Basin-scale ridge extent sectors appear in global seafloor mapping systems as large spatial regions that contain portions of the mid-ocean ridge network within individual ocean basins. These sectors provide geographic reference areas for organizing ridge corridors according to their position inside major ocean basins. The sector framework separates the global ridge system into basin-based spatial units. In the Atlantic Ocean Basin, ridge extent sectors follow the central ridge corridor that extends through the basin from northern to southern latitudes. Mapping references often divide this corridor into northern, central, and southern Atlantic sectors. Each sector contains a continuous section of the ridge axis located within a defined portion of the basin. The Indian Ocean Basin also contains several ridge extent sectors distributed across the southwestern, central, and southeastern portions of the basin. Ridge corridors within these sectors extend between continental margins and open basin regions. Global ridge maps frequently represent these sectors as connected portions of the Indian Ocean ridge network. In the Pacific Ocean Basin, ridge extent sectors appear across the eastern and southeastern parts of the basin, where long ridge corridors occupy large seafloor regions. These sectors organize the ridge system according to its spatial distribution within the Pacific Basin. The Southern Ocean, surrounding Antarctica, contains additional ridge extent sectors, where ridge corridors connect multiple basin systems. Mapping references commonly depict these sectors as ridge regions, positioned along the Antarctic perimeter. Across global seafloor datasets, basin-scale ridge extent sectors provide a geographic indexing system for cataloging ridge corridors according to their location inside major ocean basins. This framework organizes the global ridge network into large spatial sectors distributed across the world ocean. Continuous ridge corridor segments appear in seafloor mapping datasets as extended portions of mid-ocean ridge axes that maintain uninterrupted alignment across long distances. These segments represent sections of ridge corridors, where the ridge trace remains connected between adjacent structural boundaries. Global ridge maps commonly identify such segments as continuous linear features along the ocean floor. In many ridge systems, continuous segments extend between major segmentation boundaries or junction regions. Within these intervals, the ridge axis maintains a consistent structural path across the seafloor. Mapping references frequently depict these sections as uninterrupted ridge traces connecting multiple ridge segments into longer corridor units. Continuous corridor segments occur in several ocean basins. The Atlantic Basin contains long sections of the Central Ridge Corridor, where the ridge axis extends across large portions of the basin without major structural interruptions. Similar extended segments appear along ridge corridors in the Indian Ocean Basin and the Eastern Pacific region. These segments form identifiable units within ridge length reference frameworks. Each continuous corridor section represents a defined portion of the ridge axis that can be measured as a single connected structural interval. Ridge mapping compilations often record the length of these segments as part of ridge corridor inventories. The continuity of these segments allows ridge corridors to extend across large seafloor regions while remaining structurally connected. Adjacent continuous segments often meet at segmentation boundaries that partition the ridge axis into separate corridor sections. In the AIMSOL, across global ridge networks, continuous corridor segments appear repeatedly along ridge systems spanning multiple ocean basins. Seafloor mapping datasets consistently represent these segments as uninterrupted structural intervals within the larger mid-ocean ridge framework. This continuous ridge chain regions appear in seafloor mapping datasets, where mid-ocean ridge alignments occur as separated structural sections rather than as uninterrupted ridge corridors. These regions contain multiple ridge segments arranged in sequence but divided by gaps or segmentation boundaries. The ridge traces in these areas form chains of individual segments distributed across the ocean floor. In discontinuous ridge regions, the ridge axis does not extend as a single continuous alignment across long distances. Instead, individual ridge segments appear separated by offsets, discontinuities, or junction areas. So, mapping references often depict these regions as sequences of ridge segments positioned along a general corridor without forming an uninterrupted line. Such regions occur in several parts of the global ridge network. Portions of the Indian Ocean ridge system contain ridge chains composed of several separated segments positioned across different sectors of the basin. Similar discontinuous patterns appear along parts of the Pacific Ridge framework, where ridge segments occur as separate structural units along the corridor. Within these regions, ridge segments often maintain a similar orientation or alignment relative to neighboring segments. However, the segments remain separated by structural boundaries that interrupt the continuity of the ridge axis. Seafloor mapping compilations frequently represent these areas as segmented ridge chains, extending across defined seafloor regions. Discontinuous ridge chain regions therefore consist of multiple ridge segments distributed along a shared corridor but divided by structural interruptions. Each segment occupies a defined position relative to adjacent segments within the chain. Across global ridge network maps, these regions appear as segmented ridge alignments, forming chains of structural units, rather than continuous ridge corridors across the ocean floor. Ridge segment length classifications appear in seafloor mapping datasets as categories used to organize ridge segments according to their measured linear extent along the ridge axis. These classifications provide a standardized system for grouping ridge segments based on their length ranges within the global mid-ocean ridge network. In many ridge catalogs, individual ridge segments are recorded with measured lengths that correspond to the distance between adjacent segmentation boundaries. The recorded values allow segments to be sorted into different length classes within mapping inventories. Each class represents a group of ridge segments that fall within a similar range of linear extent. Some classifications include long ridge segments that extend across large distances between segmentation boundaries. These segments form extended portions of ridge corridors and appear prominently in basin-scale ridge maps. Mapping references often record these segments as the longest structural intervals along the ridge axis. Additional classifications include intermediate-length segments that occupy moderate distances between neighboring boundaries. These segments appear frequently along ridge corridors in several ocean basins and contribute to the overall segmentation pattern of the ridge system. Short ridge segments form another classification category within ridge segment inventories. These segments extend across relatively limited distances and occur in areas where segmentation boundaries appear at shorter intervals along the ridge axis. Global seafloor mapping compilations commonly apply these length classifications when cataloging ridge segments in ridge system inventories. The classification system organizes ridge segments according to their measured extent along the ridge axis within the worldwide mid-ocean ridge framework. Long-distance ridge alignment sectors appear in global seafloor mapping datasets as extended regions where mid-ocean ridge sectors maintain a broadly consistent directional alignment across large portions of the ocean floor. These sectors contain multiple ridge segments positioned along a shared orientation that continues across long spatial distances. Mapping references frequently identify these sectors as large-scale alignment zones within the ridge network. Within these sectors, ridge segments follow a common directional trend across multiple segmentation boundaries. Individual segments remain separated by structural breaks, yet the overall ridge trace maintains a recognizable alignment across the sector. Seafloor mapping compilations often depict these patterns as elongated ridge corridors extending through defined regions of the ocean basins. Several long-distance alignment sectors occur across the global ridge network. In the Atlantic Ocean basin, the Central Ridge Corridor forms a long alignment extending from high northern latitudes to the Southern Ocean region. This alignment represents one of the most prominent ridge orientation sectors in global ridge mapping references. Additional alignment sectors occur across the Indian Ocean basin, where ridge segments extend across southwestern, central, and southeastern regions along consistent directional trends. Comparable sectors also appear in the Eastern Pacific, where ridge corridors maintain extended alignment across large seafloor areas. Mapping datasets frequently use these alignment sectors as spatial reference units for describing the orientation of ridge corridors across the ocean floor. Each sector contains multiple ridge segments arranged along a shared directional framework. Across global ridge network maps, long-distance ridge alignment sectors appear as large spatial zones where ridge segments maintain consistent orientation over extended distances across the mid-ocean ridge system. Global ridge coordinate grid frameworks appear in seafloor mapping systems as spatial reference structures used to locate mid-ocean ridge segments across the world ocean. These frameworks rely on geographic coordinate grids that divide the Earth's surface into latitude and longitude intervals. Ridge positions are recorded within this coordinate structure to establish consistent location references for ridge mapping datasets. In global ridge inventories, each ridge segment is assigned coordinate points that correspond to its position along the ridge axis. These coordinate points typically represent start positions, end positions, or intermediate nodes along the ridge trace. The coordinates allow ridge segments to be catalogued within a standardized geographic grid covering the entire ocean floor. The coordinate grid framework supports global ridge mapping across multiple ocean basins. Ridge segments in the Atlantic, Indian, Pacific, and Southern Oceans are all indexed using the same geographic coordinate system. This shared grid allows ridge locations from different regions to be recorded using comparable spatial references. Mapping compilations often represent ridge traces as sequences of coordinate points connected along the ridge axis. Each point corresponds to a defined latitude and longitude location within the global coordinate grid. The sequence of points forms a digital representation of the ridge alignment across the seafloor. Global ridge coordinate grids also allow ridge segments to be grouped by geographic region. Segments falling within specific coordinate ranges can be organized into basin-scale or regional mapping datasets. Across global seafloor mapping systems, the coordinate grid framework functions as the primary spatial indexing structure for recording the positions of mid-ocean ridge segments throughout the world ocean. Basin-based ridge indexing systems appear in global seafloor mapping datasets as organizational frameworks that classify mid-ocean ridge segments according to the ocean basin in which they occur. This indexing structure divides the worldwide ridge network into basin-specific categories, allowing ridge segments to be catalogued within regional reference groups. In this system, ridge segments located in the Atlantic Ocean basin are assigned to an Atlantic Ridge Index category. The indexed entries typically include ridge segments that form part of the Central Atlantic Ridge Corridor extending through the basin. Each indexed segment is recorded with associated spatial identifiers that correspond to its mapped location within the Atlantic region. A separate indexing category is used for ridge segments located in the Indian Ocean basin. These entries include ridge segments that belong to the ridge corridors extending between Africa, Antarctica, and Australia. Mapping datasets commonly group these segments under a dedicated Indian Ocean Ridge Index classification. The Pacific Ocean basin also contains an index set of ridge segments, corresponding to the ridge corridors that extend across the eastern and southeastern Pacific region. In mapping inventories, these segments appear within a Pacific Basin Ridge Index grouping that organizes ridge records within that oceanic region. Additional index categories appear for ridge segments located in the Southern Ocean surrounding Antarctica. These entries include ridge corridors that connect multiple basin systems across the Antarctic perimeter. Across global ridge mapping compilations, basin-based indexing systems provide a regional classification structure for cataloging ridge segments. The framework organizes ridge records according to ocean basin location within the worldwide mid-ocean ridge network. Hemispheric ridge reference sectors appear in global seafloor mapping systems as spatial indexing regions that organize mid-ocean ridge segments according to their position relative to the Earth's equatorial division. These sectors divide the global ridge network into northern and southern hemispheric reference areas. The classification provides a large-scale geographic structure for cataloging ridge segments across the ocean floor. In the Northern Hemisphere sector, ridge segments occur across several ocean basins. The northern portion of the Atlantic Ridge Corridor forms a prominent example within this sector, extending through high northern latitudes. Additional ridge segments appear across northern regions of the Indian Ocean and the northeastern Pacific Basin. Global ridge mapping datasets often record these segments under Northern Hemispheric indexing categories. The Southern Hemisphere sector contains ridge corridors that extend across large portions of the Southern Atlantic, Indian, and Pacific basins. Many ridge segments within this sector occur across the ocean floor surrounding Antarctica. These segments form part of the ridge network that occupies the southern half of the global ocean system. Mapping references frequently assign ridge segments to hemispheric sectors using latitude-based coordinate boundaries. Ridge segments located north of the equatorial line are catalogued within the Northern Hemisphere sector, while segments located south of the equator are catalogued within the Southern Hemisphere sector. In many global ridge inventories, hemispheric sectors function as high-level indexing units that organize ridge segment records across broad geographic areas. Each sector contains numerous ridge segments distributed across several ocean basins. Across worldwide seafloor mapping datasets, hemispheric ridge reference sectors provide a geographic classification framework that divides the global ridge network into two large spatial indexing regions based on hemispheric location. Cross-basin ridge alignment grids appear in global seafloor mapping systems as spatial indexing frameworks used to record the directional continuity of mid-ocean ridge corridors across multiple ocean basins. The grid structure organizes ridge alignments according to their orientation and geographic position within the worldwide ridge network. Mapping datasets use this framework to track ridge corridors that extend across large sections of the ocean floor. In this grid system, ridge alignments are represented as linear traces that continue across basin boundaries through connected ridge segments. It's hoped these alignments may extend from one ocean basin into another through junction regions or connecting ridge sectors. Global ridge maps often display such alignments as long structural corridors that cross several mapped grid regions. The Atlantic Ridge Corridor forms one example of a cross-basin alignment where ridge segments extend from northern high latitudes toward the Southern Ocean region. Additional alignment grids appear where ridge corridors of the Indian Ocean connect with ridge structures surrounding Antarctica. Similar cross-basin alignments occur where Pacific ridge corridors approach ridge systems in the Southern Ocean. Mapping frameworks commonly divide the ocean floor into grid sectors that correspond to geographic coordinate intervals. Ridge alignments are recorded within these grid sectors as sequences of connected ridge segments. Each grid entry identifies the portion of the ridge corridor located within a specific geographic sector. Cross-basin ridge alignment grids therefore function as indexing structures that track ridge corridors across multiple mapping sectors of the global ocean floor. The grid system allows ridge segments distributed across different ocean basins to be organized within a single alignment framework. Across global seafloor mapping datasets, these alignment grids provide a spatial structure for cataloging the long-distance orientation of ridge corridors within the worldwide mid-ocean ridge network. Ridge system catalog reference sets appear in global seafloor mapping datasets as organized collections of indexed records describing mid-ocean ridge segments and ridge corridors. These catalog sets function as structured databases that store spatial references for ridge systems across the global ocean floor. Each record in the catalog corresponds to a defined ridge segment or ridge corridor entry within the mapping system. Catalog reference sets typically include entries for ridge segments located in different ocean basins. The entries record spatial identifiers such as geographic coordinates, segment boundaries, and associated indexing codes. These identifiers allow each ridge segment to be located within the global coordinate grid used for ridge mapping. In many mapping inventories, ridge catalog sets are arranged according to hierarchical indexing categories. The highest level entries represent major ridge systems extending across large portions of the ocean floor. Subordinate entries correspond to smaller ridge corridors or individual ridge segments positioned along the ridge axis. Each catalog entry generally includes a unique identifier code assigned to the ridge segment or ridge corridor. These identifiers allow mapping systems to reference ridge structures consistently across multiple datasets. The identifiers also support cross-referencing between ridge catalogs compiled by different mapping organizations. Catalog reference sets frequently organize ridge records according to basin location, coordinate grid sector, or ridge system grouping. This structure allows ridge segments from the Atlantic, Indian, Pacific, and Southern Oceans to across global seafloor mapping systems. Ridge system catalog reference sets function as central indexing collections that store and organize spatial records for mid-ocean ridge structures throughout the worldwide ridge network. Global ridge network registry structures appear in seafloor mapping systems as comprehensive indexing frameworks that record mid-ocean ridge segments across the worldwide ocean floor. The registry structure functions as a centralized reference system where ridge segments, ridge corridors, and associated spatial records are organized within a unified database structure. Within this registry framework, each ridge segment is assigned a registry entry containing standardized spatial identifiers. These identifiers typically include coordinate references, segment boundary markers, and catalog indexing codes. The registry entry provides a consistent reference point for locating the ridge segment within global mapping datasets. Registry structures usually organize ridge entries using hierarchical indexing levels. At the highest level, entries correspond to major ridge systems that extend across large ocean basins. Subsequent levels of the registry include records for ridge corridors, ridge segments, and coordinate-defined nodes along the ridge axis. Each entry in the registry is assigned a unique registry identifier that distinguishes it from other ridges records in the system. The identifiers allow ridge segments to be referenced consistently across multiple mapping inventories and digital datasets. Registry identifiers also support cross-referencing between coordinate grid entries and ridge catalog records. The registry structure commonly integrates entries from ridge systems located in the Atlantic, Indian, Pacific, and Southern Oceans. Ridge segments from these basins appear within the same indexing framework while maintaining their basin-specific classification codes. Across global seafloor mapping datasets, the ridge network registry structure provides a standardized organizational system for recording and indexing mid-ocean ridge segments throughout the worldwide ridge network. Across the world ocean, mid-ocean ridge systems form a vast network of connected structures stretching through multiple ocean basins. From long ridge corridors that cross entire oceans to segmented ridge axes and junction regions where several ridges meet, this global framework reveals a remarkable spatial pattern across the seafloor. In this video, we looked at how these ridge systems are mapped, organized, and cataloged through global reference grids, basin-based indexing, and structural segmentation. Together, these mapping systems provide a structured view of how the ridge network extends across the planet. If you enjoyed this quiet exploration of ocean science, consider subscribing to the channel for more calm and sleep-friendly science content. You're also welcome to leave a like and share your thoughts in the comments below. Thank you for listening, and I'll see you in the next Quiet Facts video.